Welcome to ADAS Garage, where we dive under the hood of advanced driver assistance systems. From calibrations to cutting-edge tech, we explore the innovations shaping the future of vehicle safety and automation. Buckle up, because the road ahead is smarter than ever. This podcast is brought to you by Centric, providing OEM-level ADAS calibrations designed to support your business, powered by Burke Porter.
All right, let's jump right in. Today we are taking a deep dive into automatic emergency braking.
AEB.
AEB.
Yeah.
For folks who maybe aren't familiar with this tech, can you just give us a quick rundown of what it is and what it's supposed to do?
Sure. So AEB is, one of these advanced driver assistance systems, ADS. ADS.
Yeah.
You'll hear it called both.
Right.
But essentially, it's a system that's designed to prevent those front-end collisions, those rear-end collisions that we see so much of.
Especially those ones that are, like on the highway, you're not paying attention and you're about to rear-end somebody.
Exactly.
It's like that last line of defense.
It is. It's the last line of defense. If you don't react in time, the AEB system is supposed to detect that there's a potential crash and slam on the brakes.
Gotcha. Now, you mentioned that these, rear-end collisions are really common, and I actually have a stat here from 2019. These forward motion rear-end crashes, they made up a pretty big chunk of all the accidents in the U.S.
Oh, I bet.
A full 32%.
Wow, that's a lot.
That's a big chunk of the pie right there that this AEB is hopefully going to help with.
Yeah, absolutely. And, what's interesting is that the way that these AEB systems work, they've changed and they've gotten better over the years.
Oh, really?
So initially, a lot of these systems relied primarily on cameras, so what we call vision-based systems.
Okay.
They're basically just seeing the world like we do.
Yeah.
But now there's been a real shift towards using both radar and cameras. And the reason for that is that radar uses radio waves to measure distance and speed, and it can work really well, even in bad weather, when it's raining or foggy.
Mm-hmm.
So combining these two, you get a much better and more reliable view of what's ahead.
It's almost like having an extra set of eyes or an extra sense on the road.
Absolutely.
That's looking out for you.
That's really interesting. So, we hear a lot about how these systems are making roads safer.
Yeah.
But do we have a good idea of just how much of a difference they actually make? We do.
Mm-hmm.
There was research from the National Highway Traffic Safety Administration, NHTSA, that indicated that AEB has the potential to reduce rear-end crashes by up to 49%.
That's almost half.
It's huge.
It's a huge difference.
Yeah.
So, for this deep dive, we're going to be looking at a report from AAA.
Okay.
And this was a really interesting one because they went beyond just theory. They actually put a whole bunch of different vehicles through some rigorous testing. These were vehicles ranging from 2017 models all the way up to 2024 models.
Interesting.
And they took them to a closed course and really put their AEB systems to the test.
Yeah, and what's really cool about this study is that they went beyond the typical low-speed testing that we often see. They wanted to see how these systems behave at higher speeds, 45 miles an hour, 55 miles an hour. Speeds that we encounter all the time when we're driving on highways, but that aren't always included in those standard AEB evaluations.
So they were really pushing these systems to see what they could handle. And in this report, they were really trying to answer a couple of key questions. So first, they wanted to know, has AEB technology actually improved? Is the AEB in a brand new car significantly better than what you would have found in a car from just a few years ago?
Right.
And then the second thing they were really curious about is, how do these vehicles perform at those higher speeds, the 45 and the 55 mile per hour speeds?
Yeah. Those are the key questions.
Now, one of the first things that jumped out at us when we were looking at this report is that they said that these latest model vehicles, the ones from 2024, were almost twice as likely to avoid a collision at speeds up to 35 miles an hour compared to the older models.
Wow.
And that's a pretty significant improvement. So let's dive into some of the specifics.
Okay.
What did they find when they compared the older and the newer vehicles at those kind of standard testing speeds?
Well, the results were really, really telling. They showed just how quickly this technology is advancing. So let's start with that slowest speed. They tested 12 miles an hour. The 2017 and 2018 models, so those earlier models, they managed to avoid a collision about 73% of the time, which isn't bad.
Yeah, not terrible.
Yeah, it's doing something. But when they bumped up the speed to 25 miles an hour, that rate for the early models, it dropped significantly to 47%.
So less than half.
Less than half, yeah. And at 35 miles an hour, it went down even further to 32%.
Okay. Wow.
So there was a real drop-off
Yeah.
in effectiveness as the speed increased for those earlier systems.
Okay. So that was the older generation. How about those 2024 models? How did they do under the same conditions?
Well, the 2024 models, they achieved a 100% collision avoidance rate at all three of those standard testing speeds.
So 12, 25, and 35.
Yeah, 12, 25, and 35, no impacts.
A perfect score.
Perfect score.
Yeah.
So you can really see how much progress has been made in a relatively short time.
Yeah, that's really impressive. Did they highlight any specific vehicles that sort of illustrated this improvement?
Yeah, they did. So they looked at a Jeep Grand Cherokee.
Okay.
Now, the earlier model really struggled at those lower speeds. It only avoided 20% of the collisions at 12 miles an hour, 40% at 25. And then at 35, it didn't avoid any of them.
No.
It hit the target every time.
Yeah.
But the 2024 Grand Cherokee, 100% avoidance at all three speeds.
Wow.
So a huge improvement.
Night and day.
Night and day, yeah. But it's interesting because even though it avoided the collision at that slowest speed, 12 miles an hour, the researchers noted that the braking was very abrupt. So it makes you wonder if, that's sort of a trade-off to make sure that it stops.
Yeah, you stop, but it might not be the most comfortable stop.
Yeah.
Yeah.
It's something that they may, refine as the technology keeps improving.
Yeah, interesting. What about the Nissan Rogue?
The Rogue. So the early model Rogue, it actually managed to avoid all of the collisions at 12 miles per hour.
Okay, that's good.
So that's a good start.
Yeah.
But then when they got to 25 and 35, it failed completely. Yeah, it hit the target. And the impact speeds were quite noticeable.
Significant impact.
Yeah. The newer Nissan Rogue, though, it achieved that perfect score, to 100% collision avoidance at all three speeds.
Mm-hmm.
And what was really interesting is that the report mentioned that it appeared to initiate braking earlier than the older model.
Oh, okay.
So it's not just about being able to stop. It's about recognizing that a collision is imminent and reacting sooner.
Interesting. So the timing and responsiveness have improved as well.
Absolutely.
That's cool. What about Subaru? Subaru, they often, they really focus on safety in their vehicles. How did the Outback do in this comparison?
So the Outback actually did really well in both its early and late model versions at those standard speeds. Mm-hmm. They both achieved 100% collision avoidance in all the tests up to 35 miles an hour.
Okay.
Now, they did note some minor differences in the distance it took to stop.
Okay.
But overall, both generations showed really strong AEB performance at those typical speeds.
Gotcha. So it sounds like big picture here is that we're seeing a really significant improvement in AEB technology.
Yeah.
Leading to much better collision avoidance in newer vehicles, in those everyday driving situations.
Yeah, for sure.
That's really good news. So that answers our first question, about whether the technology is actually getting better. But now let's talk about what happened when they really pushed the limits, when they went up to those higher speeds of 45 and 55 miles an hour. This is where things start to get really interesting.
Yeah, this is the real test.
Right. So first of all, before we even jump into the results, it's important to remember that only those vehicles that actually successfully avoided the collisions at 35 miles an hour were then tested at these higher speeds. So that early model Jeep Grand Cherokee and the early model Nissan Rogue, they didn't move on to this phase of the testing.
Right. They didn't make the cut.
Yeah, they didn't quite make it. So, okay, let's start with 45 miles an hour. Which vehicles were tested at that speed and what did they find?
So at 45 miles per hour, we had the late model Jeep Grand Cherokee, the late model Nissan Rogue, and both the early and the late model Subaru Outbacks.
Okay.
Now, at this speed, the Jeep Grand Cherokee, it made contact with the target in all of the trials.
Oh, so it wasn't able to avoid those collisions.
Yeah, it wasn't able to completely avoid the collisions. But the report did note that the impact speeds were relatively low. So that suggests that the AEB was still engaging, and it was reducing the severity of the crash.
So it wasn't preventing the collision, but it was at least helping to lessen the impact.
Exactly.
Which is still, better than nothing.
It's still a big improvement, yeah.
Okay. What about the Rogue at 45?
The Rogue actually did quite well at 45.
Yeah.
It managed to avoid all of the collisions in all of its attempts, and the researchers even commented that some of those stops were really, really close.
Wow. So it was cutting it close, but it was still working.
It was working. Yeah. And because it did so well at 45, it was then included in the 55 testing.
Okay. How about the Subarus? How did they hold up at 45 miles an hour?
So both the early and the late model Subarus, they also performed really well at 45. They avoided collisions in all of their tests.
Okay.
So far, so good for the Subarus.
So that's 45 miles an hour. Now the big one, 55 miles an hour. What happened when they pushed it even further?
Well, this is where the current limitations of the technology really started to show.
Okay.
So remember the Rogue that had done so well at 45?
Yeah.
Well, at 55, it unfortunately failed to even provide a forward collision warning or apply the brakes in 2 separate attempts.
So the system wasn't even recognizing that a crash was about to happen.
It wasn't, yeah. And that meant that the driver had to intervene to prevent a high-speed impact. So they actually aborted those tests because it just wasn't safe to continue.
Yeah, that's a pretty serious limitation.
It is, yeah.
Especially at that speed. All right, how about the Subaru Outbacks at 55?
So the early model Outback,
yeah,
it experienced delayed forward collision warnings in 3 out of the 5 trials. And in one of those trials, the late warning resulted in a collision. In another, the driver had to take over.
Okay.
So not consistent.
Not consistent performance.
No.
Right. And the late model Outback, the one that had done so well at the lower speeds?
Well, the late model Outback also had problems at 55. It had those delayed warnings and delayed braking, and in the end, it hit the target in all 5 of the trials. Now, it did manage to reduce its speed somewhat before impact,
okay,
but still not ideal.
So at those higher speeds, it seems like none of the vehicles were consistently able to avoid those collisions.
Yeah, that's right. And, you know, it's worth remembering that FMVSS 127, which is the Federal Motor Vehicle Safety Standard,
okay,
that actually requires full automatic braking up to 50 miles an hour.
Okay.
And dynamic braking support for those higher speeds. So the fact that we're seeing these limitations at 55, it kind of aligns with, you know, where the standards are currently set.
So it sounds like, you know, this research from AAA really gives us a good picture of where the technology is at right now. And it seems like there's some really good news in that these newer vehicles with these improved AEB systems are doing a much better job at preventing those lower speed collisions.
Absolutely. Yeah. The fact that they're getting close to, you know, perfect collision avoidance at those typical speeds that we see in cities and even on some highways, that's a huge improvement.
And even when a collision can't be completely avoided, it sounds like, you know, those reductions in speed that the AEB systems are able to achieve, that can be a real lifesaver.
Absolutely.
Potentially reducing the severity of the injuries. And it's not just about this one study, right? We're seeing more and more new vehicles coming equipped with AEB, partly driven by voluntary agreements within the industry, but also some upcoming regulations.
Yeah, that's right. By 2029, FMVSS 127 is going to require AEB in all new passenger cars and light trucks.
So it's going to be standard equipment, pretty much.
It is. And that's projected to make a huge difference, potentially save hundreds of lives and prevent tens of thousands of injuries every year. So this is a technology that's really, you know, set to have a major impact on road safety.
Which is great. Now let's think about these newer, more sophisticated AEB systems that rely on all these different sensors. You know, the radar and the cameras.
Right.
What does this mean for ADS calibration after a collision? Because it feels like it could have a pretty big impact on, you know, that whole part of the automotive industry.
Yeah, you're absolutely right. So as this AAA research really clearly shows, the newer vehicles are performing much better. And a big reason for that is that they're using these more sophisticated and more sensitive sensors. And that means that AD calibration after a collision becomes even more important.
Okay, so break that down for us. Why is calibration so important after a crash when we're talking about these advanced AEB systems?
Well, think about it. Even something that seems like a really minor fender bender, you just bump into something, can actually knock those sensors out of alignment. It can affect how they function.
Okay.
And if those sensors aren't properly calibrated after a repair, the AEB system might not work correctly.
Oh, wow.
Yeah, it might misinterpret information. It might not be able to accurately detect a collision risk.
Right.
It might apply the brakes at the wrong time or not at all.
So something that, you know, you might have thought was just a simple cosmetic fix in the past, you know, just a little dent in the bumper, could actually now have major implications for whether a crucial safety system in the vehicle is working properly.
Absolutely. And because these newer AEB systems are so integrated and they rely so heavily on this very precise sensor data to make decisions, it means that the collision repair industry needs to really up its game in terms of expertise and equipment. They need to be able to make sure that those systems are working perfectly after a repair.
So it's not just about fixing the bodywork anymore.
No, it's much more than that.
It's about, you know, making sure that these complex safety systems are restored to how they were before the accident.
Exactly.
So it's a whole new level of complexity and expertise that's required.
Yeah.
Well, this has been a really fascinating look at how automatic emergency braking has evolved from its early days to the much more capable systems that we're seeing in cars today. And the big takeaway for me is that there's been some really significant progress made, particularly in helping to avoid those lower speed collisions, which, as we know, made up a big chunk of the accidents that happen.
Yeah, I think the findings from this AAA study are really compelling.
Yeah.
They show just how much better these newer vehicles are at preventing crashes at those typical driving speeds. But, the limitations that we saw at those higher speeds, they also remind us that there's still work to be done.
Yeah, there's always room for improvement.
Always, yeah.
And research is going to be really important to continue to push that technology forward. And I think it's also worth emphasizing that while these systems are great, they offer a really valuable safety feature.
Right.
Drivers still need to be paying attention.
Absolutely.
You can't rely solely on the technology to prevent every single accident.
Right. You got to stay engaged. You can't just assume that the car is going to take care of everything for you.
And also like any safety feature, it can be affected by, weather conditions, visibility, all those sorts of things.
Absolutely.
So you still need to be a responsible driver. So as we wrap up this deep dive into AEB, here's something for you to think about.
Okay.
As AEB and all these other ADS features continue to become more common and more advanced, how is that going to change the way we think about driver responsibility?
Right.
The future of vehicle repair, and ultimately the safety of our roads?
That's a really good question.
Because these technologies are changing the way we drive.
They are, for sure.
And their evolution is going to continue to have all sorts of ripple effects that we need to be thinking about and prepared for.
Yeah, absolutely.
Well, thanks for joining me for this deep dive. It's been a really interesting conversation.
It has. Thanks for having me.
And we'll see you next time.